So hey guys, this is Dipesh, and in this particular video we'll try implementing ensemble methods in Python. Okay, so in a previous video I told you that there are mainly two types of ensemble methods, bagging and bootstrapping. So in this video we'll try to implement at least one method, one machine learning model from each type of ensemble method. Okay, so before we get started, all the code for this particular video can be found on my GitHub profile. Okay, so just go to my GitHub profile, and on my GitHub profile you'll find a repository called as MLDL course. Just click on it, and you'll find the code for all our lectures in this repository. Okay, so don't worry if you don't get understand this concepts yet. Just watch the video, and just also download the code from my GitHub profile and try to play around on your local machine. Okay, so moving forward, what we'll do is we'll first try implementing bagging. Okay, and the dataset that we'll be using is will be the diabetes dataset, the same dataset that we use for logistic regression. So if you just type diabetes dataset on Google, just type diabetes dataset on Google and click the first link that you will get. The first link should take you to kaggle.com. So here just download this dataset. Okay, this dataset is basically a dataset about people who have taken the diabetes test. Okay, so it contains features like pregnancy, glucose, blood pressure, etc. And it at the end it contains a categorical target variable called as outcome. So the outcome column basically consists of 0 and 1, where 1 indicates that the person has diabetes and 0 indicates that the person does not have diabetes. Okay, so each row basically represents one data about one particular person. So just download this dataset on your local machine. Okay, once the dataset is downloaded, what we have to do is we'll start implementing it. So let's start by importing some necessary libraries. So we'll import NumPy, then we'll import pandas. Okay, and another important thing that we'll import is the bagging classifier. Okay, so sklearn basically provides a simple API to implement a classifier using bagging method. Okay, so as I said you in our previous video that we can either use max voting or we can use averaging in bagging. Okay, so now since we are using now what we are trying to do in this particular situation is we are trying to classify between diabetes and not diabetes. Okay, so this is basically a classification problem. Now since it is a classification problem, we are using the bagging classifier. Okay, so if you are trying to do something else, so if you are trying to solve a regression problem, there is another API called as bagging regressor. So you just import that. Now as of now we are doing classification, so I will import this bagging classifier. So what I will do is I will just copy this. Okay, so what we'll do is from sklearn.ensemble import bagging classifier. Okay, now let's run it. Now also let me go and copy the path of the dataset that we have downloaded. Alright, So what I will do is I will write path is equal to, and I'll just paste the path here. So let's read the dataset. So we'll do df is equal to pd dot read csv and give it the path, and also let's print the first 10 values of our dataset. Okay. So you can see that we have we basically have one categorical target variable, okay, outcome. In this outcome column, 1 basically represents that the person has diabetes, and 0 basically represents that the person does not have diabetes. All right. Now excluding now other than the our target variable, rest all are in already in the numerical format. Okay. So we'll use these variables as our independent variables to predict the outcome. Okay. So now the next thing that we have to do is we have to split this data set. Okay. So let's define our x for, okay, our x would be everything except outcome column. So what we'll do is we'll just drop the outcome column. Okay. Now let's print x. Here you can see we have dropped the outcome column in our x, and our y would be the outcome column itself. So let's print the y. Alright. Now let's now once we have defined our x and y variable, let's split our data set. So what we'll do is I write data splitting, and let's import the train test split method from sklearn. So we'll write sklearn dot model selection import train test split. All right. Now the train test split basically takes our x and our y, and it basically returns a split data set. So it will return x train, it will return y train, no, it will return x train and x test, and then it will return y train, and then it will return y test. So let's do this. Train test split, and it will take x and y, and it will also take the size of our test data set, or the percentage of the data that we want to keep as keep for testing. So we are following a 70-30 ratio here. So 70% of our data will be used for training, and 30% of our data will be used for testing. So that's why I have written here test size is equal to 0.3. All right. So let's run this. Okay. Now also let's print our x test. As you can see, now let's print our y test. Okay. So now we have successfully splitted our data. Now the next thing that we have to do is we have to create our model. Okay. So I will write here training the model. All right. So our model is basically the bagging classifier. Okay. So what we'll do is we'll create model is equal to bagging classifier. Now this bagging classifier basically takes two important parameters. Okay. First is the base classifier, and the second is n estimators, that is number of estimators. Now the base estimator is basically the model that you want to use at its base. Okay. So basically, for example, if you want to create three different logistic regression model, then you will pass the logistic regression model as the base parameter. Okay. And the second most important parameter is n estimators. N estimator basically simply means as how many base estimators do you want to create. So for example, if my base estimator is, let's say, linear regression, and our n estimator is 10, then the bagging classifier will basically create 10 different linear regression models for us. Okay, and at the end it will basically, during prediction, it will combine their output. Okay, so let me repeat this again. Base estimator is basically the type of model that you want to create, and n estimators is the number of base estimators you want to create. So what we'll do is, since we are doing classification, let's import. Since we are doing classification, let's use logistic regression itself. Okay. So what we'll do is, I will import from sklearn dot linear model import logistic regression. Okay, then what we'll do is, we'll pass the base estimator and n estimators. Okay, so let me copy and paste this. Alright, so our base estimator is basically logistic regression. Okay, and our n estimators is, let's do it for, let's say, 6. Okay, now what this bagging classifier will do is, it will create 6 different logistic regression models. Okay, and it will train them alternately or simultaneously, and it will, at the end, it will combine the output of all the 6 models. So in order to train the model, what we'll do is, we'll do model dot fit, and we'll pass it our x train and our y train. Now let's start the training. Okay, so as you can see, we have the model has successfully been trained. So the next thing that we will do is, we'll make prediction. Okay, make predictions. So let's do model dot predict, and what this will take is, it will take our x variable. So let's predict the first row. Okay, for the first row, we know that the true value is 0, which means the person does not have diabetes. So let's copy this, and let's pass this to our model. Let me adjust this. Okay, now we know that the person does not have diabetes. Okay, so now let's the model should basically predict a probability value close to 0. So let's see what the model predicts. Okay, so as you can see, the model has predicted the class itself. So model basically does not think that the person has diabetes, which is actually correct. Now let's see the probability. So we'll do predict dot probability. So predict dot probability basically will print the probability for each class. So as you can see, the basically the first value represents the probability for that the person does not have diabetes, and the second value represents the probability that the person has diabetes. Now we know that uh, this person does not have diabetes, and therefore the model has basically given a higher probability for the first value. So this is how we make prediction. Now also let's find out the accuracy. Okay, finding the accuracy. So what we'll do is, we'll do accuracy is equal to model dot score, and what it will take is our x test and our y test. Okay, let's print our accuracy now. As you can see, our total accuracy is 77%. Okay, if we change the number of base learners, okay, if we, let's say, from rather than using 6 we use 10. Let's see how this affects the accuracy. So as you can see, it hasn't changed the accuracy yet. Okay, so this is how we use bagging. Okay, remember we use bagging classify here because we are solving a classification problem. If you are using something like, if you are doing let's say regression, then you will use a bagging regressor here. Alright, so now the next thing that we'll do is we'll try implementing a boosting method. Okay, one of the most common boosting method is called as AdaBoost. Okay, so what we'll do here is we'll do boosting. Okay, so one of the most common algorithm uh, for boosting is called as AdaBoost. Okay, now since we are solving a classifier problem, we'll use AdaBoost classifier. The sklearn library basically gives us a very easy API and gives us a very simple implementation of AdaBoost. So all we have to do is just call this method and it will automatically train the model and do all those stuff. So let's do this. So what we have to do is just copy this sklearn.ensemble.adaboost classifier, and what we'll do is we'll import this. So I write from sklearn.ensemble import AdaBoost classifier. Alright, now since our data set is already like split into training and test set, we don't have to do much. All we have to do is just directly train the model. So again, like even for the AdaBoost classifier, we have two main parameters which are the same as the bagging classifier. Okay, the AdaBoost classifier again takes a base estimator and it also takes the number of base estimators. So what we'll do is I will try to use the same base estimator and the same number of base estimators. Okay, so what I'll do is I'll just copy and I'll paste it here, and rather than using bagging classifier, I will use AdaBoost classifier. Alright, so after doing this, let's find out the accuracy for our model. Let's run this. Okay, so our AdaBoost model has successfully trained. Now let's find the accuracy of this model. So you can see the accuracy is somewhere around 74%. So let's try reducing the number of estimators. Okay, see now the accuracy increased by 1%. Okay, previously it was 74%, now it grew to 75%. Now remember that in order to find the basically the number of estimators is a hyperparameter. Okay, think of number of estimators as a hyperparameter. There is no the model will not find the number of estimators for you. You have to basically give it to the model. Okay, it is very similar to what we did in k nearest neighbors. Okay, the only way to find the best n estimators is to basically train your model on a bunch of a different number of n estimators. Okay, so train your model on a large number of n estimators. Let's say start from 0 and then go about till 100. Okay, now after that what you do is you choose the model which has the highest accuracy. So it is basically the same concept that we did in k nearest neighbors. So yeah, this is how we implement bagging as well as boosting.